Very nice. Alex.
Okay.
Okay, so
going here.
Okay, perfect. I'm muting myself.
Okie dokie. Hi everyone. So today, oops, change the. See if I can change the screen here. There we go. Okay. I think that's showing okay. So today I'm going to talk about a new series that I'm putting out of net artwork. I've been calling Chow, Code In, Art Out. And the one sentence tagline for this is it's a set of self-contained digital artworks that are rendered in a standard web browser. So I'm going to quickly change over to Chrome here. This is a live demo, which always can be tricky. So the self-contained idea is that you can copy the code for the artwork, paste it into a web browser address bar, and press enter, and get that complete artwork. And this is not hosted online anywhere. All the code needed to render this particular artwork was in that cut and paste that I just did. So here's another example. Again, quite different. That one's based on Conway. I'll also put these in the chat towards the end of the presentation. Kind of a wandering one. And this last one is a static image of an artwork. The other interesting thing you can do is right click and save this image, and you get a full 600 DPI rendering of the original artwork that you could or could not print on your own, which raises some interesting questions. So going back to here, I'll read my statement about this. It might be a bit helpful. So high-level computer code is representational language of mathematical logic from which seemingly infinite complexity can arise. Stemming from the most basic logic of 1 and 0, on and off, true and false, code's purpose is to abstract fundamental digital operations into a human-readable and understandable form by leveraging the conventions of language and mathematics. The complexity which arises out of simple rules weaved together creates beauty from this conceptual yet constrained instruction set. Much as how nature makes grand structures from numerous discrete units. So this particular series arose out of a few ideas I had been looking at. So this work from 2017 are 2 oil paintings, and on the left is the web page code for the image that it produces on the right. And this was all rendered by hand in oil paint, sort of switching mediums, which I found quite interesting. I also made a website called 4qr.xyz that was picked up by a couple sort of hack blogs. The idea here was similar, that you could go to 4qr.xyz, make a web page, and host the entirety of that web page in this sort of link. So that the web page isn't actually hosted anywhere. All the information to make a web page is contained within the link itself. I also did a few works using crypto. So these were custom tokens I made on the Ethereum blockchain called token art. So you could own one of these tokens. I gave them out at a gray area festival a few years ago. And inside these envelopes were the private keys to own these tokens. But in themselves, these tokens aren't artworks. They're just the keys to produce artworks. But the interesting thing is that they can produce multiple different types of artworks. So here's one particular output when you would scan these badges. So that it would create a poem, which is unique to your token. It could create a sticker unique to your token. Or another example, you could go up and scan the work, and it would create a large-scale projection based on your token in real time. And you could own and trade these tokens, but the actual artworks that the tokens made were not in themselves ownable. They needed to be rendered every time. Also been interested in things like Augmented Reality. These are a bunch of AI-generated faces on a postcard that I give out. Sort of fun seeing them attached to physical objects. So that all these ideas sort of came together, I guess. I've been working on this particular concept maybe since 2016, but now during the pandemic, it seemed more than ever, it'd be interesting to do something that you could share in a non-centralized way and use the internet, not just as a medium to like put up pictures of artwork, but use the actual engines of web browsers themselves as the medium. So over 53% of the world's population has access to a web browser, which makes a web browser the most ubiquitous way to render digital art versus any sort of other outputs. Also, if you make code that's compliant with web browsers, you have a pretty good chance that it's going to be archival in the future because web browsers have to be quite backward compatible. Unlike, say, doing digital art on a Betamax tape or something in the past where the medium can become expired, it'd be very rare for the artwork I'm doing here to not be renderable in the future because it's so standardized, and I'll get a bit into the code later. So this all works around a concept that not many people know about called a data URI, and this works in all web browsers except for the ones put out by Microsoft, naturally. So the idea here is that if you put in this text data /HTML, everything after it will be treated by the web browser as valid HTML and JavaScript code. So what this means is you can basically embed an entire web page in that cut and paste code that I showed before. And you can see the example below here where data text HTML just makes a little hello world in a heading. You can type this into a browser yourself and give it a try. Yeah, my idea was to combine the output of the code, the sort of aesthetic object, with the code itself. And as far as I know, in the research that I've done, I haven't seen any other artwork which has actually included the code which produces it in itself, which to me is kind of an interesting recursive addition. The QR code included with the artworks basically encapsulates all the text that you would need to paste into a web browser. It just makes it easier for you to scan it with your phone, copy it, and render it yourself. There's a bit of a close-up. You can see how the sort of two objects are contained within each other. So I gave myself a series of constraints, as one does. In this artwork, all these things are true. So it uses what's called vanilla JavaScript, and JavaScript's the language that's used within web browsers to make these programs. And it doesn't rely on any external code, which is not included with web browsers. And it does not actually require internet access. So you could completely go offline and paste this code into a browser and it would still work. It only uses US keyboard characters. That way you could copy it by hand if you needed to from, say, something that's on a wall. It fits within the constraints of a QR code, which mostly means that it has a certain length limit. It runs in the top two most used web browsers at the time. I think right now that's Chrome and Safari. It's a W3c Valid Code. W3c is the standard organization. So basically this just means is the code that I make has to not have any errors. It runs by pasting into an address bar. And for any output which differs between web browsers and operating systems, I render it on the most used browser. So as you saw in that example of a print, the archival medium I'm using is paper and ink, but you also could copy that code and share it or store it digitally. There are several ways to actually render the artwork from the code. One is you copy it with your eyes, so you just take a picture of the artwork, look at the code, and retype it and paste it into an address bar. You could save it as an HTML file. That also works. So you could just put it in the text editor and save .htm. You can scan a QR code with the app and paste that result in output. And again, you can scan the QR code as an HTML file. There are some non-archival ways that I have going right now that makes it easier to use. So I have a website, qr2a.xyz, which I'll show in a little bit, and that automatically renders the artwork. And there's also a hash URL link that basically is a way to share a link that immediately also renders that artwork. So there's several ways to put it out there. And yeah, right now on QR2A, I have a QR code scanner and a hash code forwarder. This hash address here is that that hello world example put as a link, and I'll also have a gallery on there. So here's an example of a printout. So yeah, it's just a QR code scanning app. You copy the code. Again, this is being done on mobile. You paste it into your address bar and just hit go, and it's working. And again, this will render the artwork whether or not you're connected to the internet. So it doesn't actually rely on any external connectivity. So getting into the code, here's the code for that example that you just saw. There seems to be a lot to it, but I'll quickly go through all of it. I think it's easy enough for people to understand if you go line by line. The actual code that makes the particular artwork is this highlighted bit. The rest of this code is sort of housekeeping to align things and set sizes and have helper functions and that sort of thing. So the first line we get, again, is that data text HTML that basically tells the browser that what's about to follow is HTML and JavaScript type code. Then you have doc type HTML, which is required by the W3c standard that, again, tells the browser that what you're about to see is a document of type HTML. And then there's this little funny bit, which is sort of unique to me. The first 5 characters are a unique identifier that I have for every edition of all artworks that I make, digital or not. And the remainder is a bcrypt hash using a password that I only know. And in this way, no other artist can make artwork, which they could pass off as mine without actually having my password. So this is a way for me to authenticate both digital and physical artworks. There's a title. In this case, it was called Bad Scrubber. And this is generated from that art ID number. So every artwork has a generative title. This is a bit of style code telling the browser to set everything centered and make it the full screen and have a black background and that sort of thing. And then we start with telling the browser we want to draw on the browser screen. So we set up something called a canvas. This is the seed number. So this is a number that actually defines the output of the artwork. So each artwork has a unique seed number, which is deterministic of its output. So if you were to change this number by 1 digit, you would get a completely different output than the others. So this is the actual number that defines what this artwork is. This sets it to a width and height size in pixels. This gets a context from that canvas. This is kind of an important bit. It looks kind of complicated. It's what's called a pseudo-random number generator. And basically, it takes that seed number and generates a whole bunch of numbers that appear random from that number. But since it's something called deterministic, it will always be the same random numbers every time, which is why that seed number defines the aesthetic output of that artwork. And here's where the actual code for making the art comes into play. This is an example of just making a red rectangle that starts at 0, 0 position and is width by width size. This is an example of a rectangle. And then it ends with an end script tag. That's pretty much it to the code. Getting into what makes it interesting is, like I said before, creating complexity out of simple algorithms and input. So here's a square with 1, 2, 3, 4, 5, 6, 7, 8 points labeled A through H. You can connect these points with lines in these 10 ways. So you get these 10 varieties of things. You can take any of these tiles and rotate them each by 90 degrees. So then you get 4 different outputs. So if you coded that up, you could programmatically make very complex looking output from those very simple rules. And this is how the code gets built up from these simple ideas to complexity. Here's with the colors. Then you can do things that are like black and white. Then of course, you can get fancier. So I started going down a rabbit hole with these, what they're called Truchet, I believe, curves. A few different varieties of output. This one's quite colorful. There are more black and white. The animated ones I quite like. They're quite glitchy. Then you get into yeah, all sorts of weird and complicated things. Again, these follow the same rules, but I'm just sort of playing with the way that the rules are interpreted by the system. You see a bit of an animation here. So I'll quickly go through a whole bunch of other examples of types of prints and outputs that I've been making. I'll put a link at the end of the presentation, or you can check out a whole bunch more on my Instagram and other pages. Here's an example of what a print would look like from this particular output. Again, you see the tree on top and the code and output on the bottom. And then the same tree code, but sort of mashed up with colors and different parameters, creates these quite wild outputs, sort of space invader-y type code. And here's a couple more examples. When the code makes animations for the prints, I put frames at different time intervals. So there's a grid of frames because you can't really capture statically what an animation is on a piece of paper. So here are a few examples of those. And again, a few more sort of outputs that I'll go quickly through. Sort of fun jiggly Necco wafer animations and sort of fun Starscape type ones. Yeah, so quickly to sort of wrap things up, there are other, besides prints, there are other fun things to do. So this is a receipt printer with a big red button. Every time you press the button, you get a unique artwork that you can take home and scan yourself and render. And this is sort of playing with the idea of the art object being precious. Here it's a quite disposable piece of receipt paper that creates a very complex output. And again, this all works with that sort of cut and paste mechanism. And if you were to, say, collect the receipt printer itself as an art object, you can create nearly infinite artworks from that object. So it really questions what the artwork is in this case. Is it the receipt that's coming out, or is it the system that prints those receipts? And yeah, given my background, I obviously can help sort of adding robotics into it. He's sort of a pen plotter doing one of these curve outputs. I have a video on my Instagram if you want to watch the full thing, but this is the output using a calligraphy pen, which is quite beautiful. And here's an example of a song that's encoded in a QR code and output. So the synthesizer, the visualizations, and the entirety of the information needed to make this piece of music is encoded within that QR code and that text. Obviously, it's a simple song, but a song nonetheless. Okay, I think that's my time. I'll paste a couple examples of those cut and paste things in the chat. It's not really public right now, but if you want to play with some online, you can go to qr2a.xyz/gallery. My Instagram and Twitter is at artpoffin. And these will be premiering at a online show at the Kate Vass Gallery in early July. So you can check these out there. Thank you.
Excellent.